Hello class, and today we're going to look at part 6 in our chapter of pressure, and this part 6 is we're going to talk about gas pressure. So pressure comes in a lot of different forms, as you can see. In the first part we looked at pressure between surfaces or between solid surfaces, and the second part and the third part we look at liquid pressure, and the fourth and fifth part we looked at atmospheric pressure. Now we're going to look at gas pressure. Gases can also exert pressure, and a gas consists of tiny atoms or molecules that move around all the time. So here I have a simulation that shows you how gas particles exert pressure. So in this simulation, I have a box or a container, and with this container, I have a pressure gauge here that measures the pressure, and I have a thermometer here that measures the temperature. So I'm gonna put in gas particles inside this container or inside this box, and we will see what will happen. So I'm gonna give 3 pumps. Okay, so as soon as there's gas molecules inside the container, you can see there is pressure inside this container. So how do these gas molecules exert pressure? So if you look at very closely, the gas molecules are moving and they are colliding with each other, okay? But they are also colliding with the box or with the surface, with the walls of the box. So every time they collide with the wall of the box, they exert a force on the box. And when they exert a force, that will bring about pressure inside the box. So as the gas atoms or molecules move, they will hit us or a surface. Each time they hit, they exert a force, and therefore they exert a pressure on us or the surface. When one tiny molecule hits us, we do not feel a thing. The force is very small. But if there are a lot of molecules hitting us, the pressure exerted by all the molecules can be considerable. So, if you put a gas in a container like a box or a bottle, the gas molecules are moving inside the container and hitting the walls of the container all the time. So, the gas is exerting pressure inside the container due to the collision that the molecules are making with the wall of the container. So very important, where does the gas pressure come from? The gas pressure comes from the collision between the molecules and the wall of the container. What happens if we put in more gas molecules inside the container? So let's use this simulation again to show what happens. So you can see right now the pressure is about 13 kilopascal. So if we put in more gas molecules, what will happen? So I'm going to give 3 more pumps, 1, 2, 3, doubling the amount of molecules. You can see the gas pressure now increases to about 2,300 or 2,200 kilopascals. I double the amount of gas particles here, and the pressure is double as well. If you put in more gas molecules inside the container, the pressure would increase. Why does this happen? You can imagine it just like in a bus. If you have a full bus, it will be crammed if there are a lot of people in it. So if the container is crammed with gas molecules, there are a lot of gas molecules in it, the more they are in the container, the more collisions they make with the wall of the container. Okay, so when there are more collision, that means the pressure will increase. Now, what other ways can you do in order to increase the gas pressure inside a container? If you want to do that, you just have to make sure that the molecules make more collision. One way is to make the container smaller. Here I have the simulation again. The pressure is at about 23 kilopascal. If I make the container smaller, let's say about half the size, so the molecules have less space, or in other words, they have less volume. So the container has less volume. What's going to happen to the pressure? So right now it's 22 kilopascal, and now it has jumped to 46 kilopascal. So if you have a small container, a smaller space, a smaller volume, the pressure would increase. What if you go the opposite way? Let's increase the pressure this time. And you look at the pressure gauge there. So if I increase the volume, increase the space, or increase the size of the container, the pressure goes down. Now, why does this happen? When the container is smaller, the molecules will have more and frequent collisions if the container is smaller. So if you have more collision, that means the pressure is also more. If the container is larger, it will have less collision, so the pressure will decrease. This shows that the gas pressure is affected by the volume of the container. So to summarize what we covered in this video lesson, you need to know two things. One, where does gas pressure comes from? Gas pressure comes from by the particles colliding with the surface of the container, creating pressure. The other one is the relationship between pressure and volume. How does volume affect pressure? So if you have a large volume, that means if you have a container with a large space, the pressure will be smaller because the particles will collide less frequently. And if you have a smaller volume or less space inside the container, the pressure will increase. You have more pressure because with less space, the molecules will collide more frequently with the wall of the container. Next video lesson, we're going to look at how to calculate gas pressure using something that's called Boyle's law.